Okay, the limit is used for that. So, so the limit, I usually explain it like it's a game. Okay, and the game is that you can ask me, the game is that you're supposed to guess the value when x equals a. You're supposed to guess the height when x equals a. And you can ask me the height anywhere else, and I have to tell you. So you can say, here, what's the height, here, what's the height, here, what's the height, here, what's the height, here, 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 here. Okay? You can ask any question you want, and I have to tell you, except you can't ask exactly at A, because that's what you're supposed to guess. Okay? So, and the limit, the meaning of the word limit is basically what you would probably guess. So, when I say the limit of f as x approaches a, that's how you read that. That just means what you would guess if you played this game. So what would you guess if you played this game? So, you know, you can't see the picture, right? But you can ask the questions. So somebody says, okay, what is it here? So I have to say, oh, it's whatever that is, right? And then somebody says, well, what is it here? And then I have to say, oh, it's whatever that is, right? And then somebody else says, oh, well, what is it here? And I have to say, oh, it's, that didn't work too well. Oh, yeah, it's here, right? And so on, right? You keep doing that. And you're allowed to keep asking until you get tired of asking. And then you have to make a guess. Okay? So what are you going to guess? What I mean is, are you going to guess that the height is c? No way. Right? You have no reason to guess that the height is c if you're playing that game. Right? If you can't see what it is exactly at A, there's no way that you're going to guess that the height is c. Right? Why would you say c? Right? It could be up. If you're going to say c, why don't you say somewhere else, like up here, down here, and down here? Right? There's no reason for you to say any of those. So what are you going to guess? Well, I'm suggesting that you're going to guess something close to what? To B, right? Okay. So what you would guess is called the limit. Okay? So the limit is equal to B. However, this is not the same thing, right? F of A is not equal to B, right? F of A is equal to what? C. Okay, so F of A equals C, but the limit is what? Is B, right? Is that clear? Okay, so that's the point of a limit. So it's telling you not what's happening exactly at the place, but just what's happening near the place. Okay, and that can be useful. Okay, so that's a tool that you might use, and we have to use the limit to talk about derivatives, turns out. But just for looking at a function, it could be useful. So going back to this function, not this one, but the one that they gave us. Going back to that function, I could ask you the limit at many different places, at any place. Okay, but the interesting place to do it is where it has some particular sort of problem. So where does this function have a problem? When x equals -1, right? Remember we said it's not defined at -1. So we can ask the limit anywhere, but the one that's kind of the most interesting is that one. Okay? So that is the question that they gave us. And how do we figure it out? Because we can't just put in -1, right? Because It's not defined there. Okay? So we need to figure it out. So the way to do it, well, let's watch it. Anyway, does everyone understand this issue? Right? What's the limit? Right? Means what does it get close to? Okay? Just like in that picture that I drew, the height gets close to b. Right? So that's the kind of question we're asking. So why we're doing it might not be so clear, but we just need to learn how to do this. So let's see what they say. How are they going to do this? So they're doing this problem, which is close. Was that the same one? No, almost the same, right? This is x squared plus 4. This is x squared plus 1. Otherwise, it's the same, right? Okay? So it's almost the same problem. Let's see how they do it.
Estimate the limit numerically. The limit is x approaches -1 of x squared plus 1 over x plus 1. So we cannot simply plug in -1 because we'll get 0 in the denominator of the fraction. So we need...
One other thing, I just want to do one thing first. Let's just get used to reading this symbol. So first of all, let's get used to reading this symbol. So how do I read that? I've said it already a couple times, but I'll say it again. This is read, x approaches -1. Okay? So I hate to do this, but I'm going to ask everybody to repeat it with me. Okay? Can everybody say that together? Good. Do it one more time. And one more time. Right. So, because you just need to get used to that. Okay? So that's x approaches -1, right? And then you read the whole thing as, this part you read, the limit of, and then you read the function, and then you say as x approaches -1. Okay, so let's read it again. Or let me read it again. You say the limit of, and then you read the function. So you say x squared plus 4 over x plus 1, right? And then you say as x approaches -1. Okay, so that's exactly this question that we're trying to ask, right? Which we're saying, what happened? That whole sentence means what happens to this as this value, as we get closer and closer to -1, as the x gets closer and closer to -1, right? That's what we're asking. I'll read it once more. We read it like this: the limit of, then you say the whole thing, x squared plus 4 over x plus 1, as x approaches -1. Okay? So that's like the hardest part of the whole thing. It's just learning how to read it. Okay? And once you learn that, it's not too confusing after that, actually. Okay? So, all right, so anyway, so he said we need to use it. Okay, so let's go back.
And -1, because we'll get 0 in the denominator of the fraction. So we need to use a table of values, and we're going to plug in values that get very close to -1 from the left and the right. So
wait, I can't seem to get this to show up, right? Will that help? Right now. No. I can't get it to show the caption. All right, let's try that.
when doing so,
So he's making a table.
we use -1.1, which gives us -22.
So he's going to put it, the thing is that we want to choose value. I remember the game was that you could ask me anything and then you have to guess, right? So obviously we want to ask things that are close to -1. So that's what he's going to do. He's going to start with this, which is pretty close to -1. And then he's going to get something that's even closer to -1, and then closer and closer. And that's from the left of -1, from the values that are less than -1. Then he's going to also choose values that are slightly higher than -1, and choose values that are closer and closer. So he's going to just do that and check what's happening, what is the height at all of these things, and then you're supposed to make the guess, right? And what you're going to see with this one is that it's kind of going to blow up. So these values are going to get very big. As you choose values that are closer and closer to -1, these values are going to get very, very big. But coming from the left-hand side means values that are actually less than -1. The whole thing is going to give you negative numbers, which are very big. So there's going to be large negative numbers. But if you come from the right-hand side, you're going to get large positive numbers. Okay, so then the graph is going to have to be drawn accordingly.
Point 1, we use -1.01, which gives us -202.01, -1.001, which gives us -2002.001, -1.0001, which gives us -20,002, -1, which is undefined because 0 will be in the denominator, -0.9999, which will give us 19,998.0001, -0.999, which will give us 1,998.001, -0.99, which gives us 198.01, and -0.9, which gives us 18.1. So as we can see from the table, at -1.0001, we have -20,002, and at -0.9999, we have positive 19,998.0001.
So if I asked you to guess now, it would be kind of like you couldn't really make a guess, right? Because you might say, I can't get rid of this thing, but you might say, what was the first number? This number was like 20,000, and this, no, sorry, negative 20,000, and this was positive like 20,000. So then, you know, what are you going to say, right? There's no answer, right? Okay, so in that case, actually, what we're going to say is that there is no answer. There is no guess that will be correct. So in that case, we say the limit doesn't exist. Okay? So that's a special situation. Because if you can't if you can't come to a conclusion, then you have to throw up your hands and say, I don't know. In other words, throw up your hands and say the limit doesn't exist. Okay? So, okay, but let's see what he says.
So our values are going to two different places for f of x, one being positive and one being negative. So therefore, the limit does not exist.
Okay, now, on the other hand, we can certainly get a good idea what the graph looks like there. Right? Because what was it coming from the left? It was negative 20,000. And coming from the right, it was like positive 20,000. So, we can get a kind of good idea of what it looks like there, even though the limit doesn't exist. So the idea that we can get is, what did we say? Coming from the left, it was negative? Negative 20,000, right? So maybe it's going to look like that, going towards negative infinity. And here, from something like that. Going to positive. So we get a good idea of what it looks like, but in terms of whether the limit exists, we say no. Okay? All right, so what do we have to answer in this answer? Yeah, that's right. So it says, estimate the limit numerically if it exists. If you need to, so we're allowed to use these symbols, positive infinity and negative infinity, but in this picture, you can't use that because one of them is positive and one is another. When the thing about limit is it has to be, you're only allowed to give one answer. So the limit has to be the limit, not a limit. Okay, so there is no the limit, right? Because you'd have to give two answers. You can't give two answers. So they say, or you can enter, or sorry, you can write infinity, or finally at the end, if an answer does not exist, then you type in this. Okay, so that's what we have to type in here. Okay, and let's see if they accept that. Yes. Okay, does everyone get it? Everyone understand this problem? Okay. All right, let's practice reading this before we go on. So first of all, how do you read, sorry. First of all, how do you read that? X approaches 0, good. Okay, now the whole thing, how do you read it? You read this first, so you say the limit, and then you say of, and then you say this part, right? So you have to read that, x minus 20 over x minus 5, and then as x goes to 0, or x approaches 0. Okay, that's how you have to read this. Okay, now we know how to read it. Now, the question is, what is the answer? Okay, now this one is a little surprising, sort of, because this doesn't have a problem when x is 0, right? It does have this function does have a so-called problem, but not at 0, not when x equals 0. It has a problem when x equals 5. So if they had asked us that, that would be kind of more standard limit question, because we usually only want to ask limits where there's a problem, because otherwise we don't need the whole thing about limits. We can just say, oh, I mean, in this case, when x goes to 0, you don't need to sort of do all that guessing, because you're allowed to just put in 0, so obviously, or pretty obviously, it's going to be approaching that particular height, right? So you just put in 0, so what do you get? Negative 20 over negative 5, which is 4. So, there's no issue there. You don't have to do any big thinking, right? Because when you get closer and closer to 0, there's not anything that's going to be strange that's happening. It's just going to be getting closer and closer to 4. Okay? So, in that case, this is kind of like, using a machine gun. Well, let's do a better analogy. Using, some big tool just to do something really simple, right? Using a cannonball to hammer a nail, right? You don't need to do that, right? And you don't need this limit stuff to ask about what's happening near 0. Okay, you can use it, and the answer will be just put in 0 and find out, because the only case where that won't be true, where you can't do that, is when you either get like 0 in the top, or 0 in the bottom, or both. Actually, 0 in the top by itself is no problem. But 0 over 0, or something over 0, those are problems. Also with square roots, you can sometimes need a limit, because there's sometimes where you get things that are not defined. But, okay, so that one is pretty straightforward. However, this one is more, so what do we put in here? 4. Right? Let's see if that works. Okay, that seems to work. Okay, now we have this one. Now this one is a little bit more useful, right? Because it's asking near 8, and 8 is actually an issue for this function, right? So now we need to do the same table that he did for the last one. Okay, now there's no video for this one, but you just have to put in the values, and I think this is going to be the same kind of answer as the last one. I think it's going to be go to positive infinity on one side and negative infinity on the other. So I think we're going to have to put in, let's see if I'm right, D and E, without actually doing the work, which you have to do. So this, I think the answer is just going to be that. Yeah. Okay, so that's basically the same problem as this one. Okay. Let's see, do we have anything else? Okay. Right, that was a really long one, so I'm not going to do that. It says click here to begin. So how about this one though? So here we don't give it, I mean, this is still a function, but they don't give us a formula for it. Instead, they give us the graph of it. But still, the graph explains the function, right? I mean, you can use the graph to, like if I ask you, what's the height at A, what would you say? Negative 2A, right? Right? If A is 9, so if I ask you what's the height at 9, you would say what? Negative 18, right? So you can use this picture to tell you, you know, the